Take a look at, can you guys see my screen? Good? Okay, so let's go ahead and we're gonna graph the top three. So the first one, okay, says x less than or equal to 3. So remember from last time we talked about that anytime that it's a less than or equal to, you're going to use a closed dot. So we're going to put that right there on 3. Okay, and then I can see that it's a less than. Remember, we kind of said that's like an arrow telling me to point to the left. So I'm going to shade this direction. Okay, you can also think about that since it's a less than, it's to the left, both L's. Think about going smaller, whatever you want. Okay, next one for B. We have x greater than 1, so I'm going to do an open circle here on 1. And then I see that it's a greater than. You can think about like it's an arrow to the right, okay, which means that I'm going to shade this way. And then for my last one, we're doing from 4 to 6, so I'll do an open circle on 4, closed circle on 6, and then I'll shade in the middle. And so remember last time we were looking at the number lines, writing the set notation, now we're just kind of reversing that process, okay? So remember also that what happens is when you have this symbol right here, okay, this is called a union. Oh, you still can't see the notes? Oh, no. Hold on. Y'all couldn't see them this whole time? No. Now, can you see them?
Yes.
Yes? Yes. Sweet. Okay, so I'll give you a sec to get caught up on that. If you want. Okay, so for the first one, okay, sorry that you couldn't see it. The equal to tells me that this is closed versus like over here, there's no equal to. That's how I know it's open. Okay, then remember for a less than, you shade to the left, and for a greater than, you would shade to the right. But then whenever your x is between two numbers, like you see here, that means you're going to shade between those two dots. Okay? All right, so now kind of getting to the pre-cal part of this, right? So those number lines you've seen since like Algebra 1, right? Okay, but the U, we talked about last time, is a union. And basically what that means is that you are going to combine the number lines. So what I'm going to do is I'm going to graph them on top of each other on the same number line. So I'm going to have from, what is this, 3 closed to the left, because that's my A. And then I want to union it, okay, with B, which is here. So I have 1 open and then to the right. And then what I want to do is think about if I were to kind of like stack those on top of each other, how much of the number line would end up shaded? Okay, well think about, I'll do it maybe in like a little pink color. Okay, here I do 3 to the left, but then I do 1 to the right. How much of the number line ends up getting shaded? Once I stack. Okay, now for a union, remember, if it's shaded on top or on bottom, shaded in the middle. I'm not looking for the overlap yet. So if I want either one, yeah, then it would be everything. Okay, this whole way across. Because remember that for a union, you're saying like, okay, the top wants to shade all the way to the left. We're going to do that. The bottom wants to shade all the way to the right. Okay, well, we're going to do that. Well, we just shaded the whole number line. So remember that you have the option of doing negative infinity to infinity, or you can do your little R symbol. And remember, that's because the entire number line, when I line those up right on top of each other, everything ends up shaded. Okay? All right, now right next to that, we're going to flip that symbol over. Okay, this is an intersection. Okay, and an intersection is where you look for the overlap in shading. So it can't just be shaded on the top or the bottom. You can only shade the sections that are shaded for both. Okay, so I'm going to real quick just sketch. I have a closed dot to the left. I have an open dot to the right, but then I'm only going to shade in the middle where I see that overlap happening. Okay, so if you heard what Thomas said, okay, I'm only going to shade between 1 and 3 because that's where I see this overlap. Now, the one thing you do have to be careful about is your endpoints. So when I'm doing this guy over here, the bottom did not shade 1, but the top did. That left it shaded, right? So for a combination, if either one of them shades it, that's good enough. Okay, but for an intersection, they have to both choose to shade whatever section or number. So when I look at 1 is shaded at the top, but it's not shaded at the bottom. That's gonna leave not shaded in the middle because they have to both agree to shade it in. Okay, now let's talk about my endpoint 3. 3 is shaded on the top because it's a closed dot and it's shaded through on the bottom, then it would be shaded in the middle. So that would tell me that my 1 is gonna stay open and my 3 is gonna be closed. So I would go from 1 to 3 closed. And then remember, we talked about that yesterday. Okay, but your bracket is closed, your parentheses is open. Questions about that? Okay. All right, next one, we want a union A and C, okay? So A is 3 to the left. C over here was from 4 to 6. Remember, 4 was open, 6 was closed, shaded through the middle. So remember, for a union, I'm just combining the shading. So I'm like, okay, well, I have some shading here. I'm gonna definitely copy that. Then I have some shading here. I'm gonna definitely copy that. Doesn't matter if they overlap. I'm just basically taking anything that's shaded, combining it onto the same number line. And then what you're gonna notice is that you end up with 2 sections of shading. Okay, so I have this section here, and then I have this section here. So the little U that you use up here, we're gonna reuse that. We're gonna say this is from -infinity until 3, union, and then 4 to 6. So the U basically means like, and you have another section besides that, okay? So you can use that to just say if you have multiple parts. So we can write that right here. Okay, that's if you have multiple sections. All right, now let's do the next one. So my A and my C this time, they're gonna be intersected. Remember, intersection means that I need the overlap. Okay, which we already wrote up there at the top, but we need the overlap in shading. So my first guy was from 3 to the left. My bottom guy was 4 to 6. Okay, do those overlap? And if they do, where? Anybody? Do those shadings overlap or no? They do not, correct. So what you would say for that, since there's no intersection, is you would do this guy, which if you don't remember that from last time, okay, that's the empty set, which basically means there's no overlap. Okay, so you would say there's no section of that number line where it was shaded above and it was also shaded below. That didn't happen, so I would put the little 0, okay? All right, so we have one more version of that we have to do, and that's where you're starting with interval and you're going to set, okay, but it's basically the exact same thing. Okay, so I'm gonna do 1 to 4. Notice that those are both open. So 1 to 4, and then 2 to 7. 2 is closed, 7 is closed. And then remember that if it's a union, I'm just combining those on top of each other. Okay, so what I would do is I would start with one line, then I'll put the other line on top of it. So I'm like, okay, well, I'm gonna start at 1, stop at 4, but then when I come down to this number line, I'm putting a closed dot on 2, and then I'm gonna shade all the way until 7. So basically, even though the 4 was not shaded on the top number line, it ends up getting shaded by the bottom number. So my ending interval ends up looking like this, where I would have shaded all the way from 1 open to 7 closed. So again, if the top didn't shade it, but I stacked the bottom one on it, well then 4 ends up getting covered up to where it's not open anymore. Okay, so then I would say that's from 1 to 7. And then notice my 1 stays open because nobody shaded it, but my 7 stays, oh wait, my 7, oh yeah, stayed closed. Questions? We're good so far? Okay. All right, next one, we have 1 to 4 here. We have 2 to 7 here. But now we're looking for the intersection. And remember, the intersection, they both have to agree to shade in the same spots. So I would say, okay, well at 1, it's shaded up here, but not down here. That doesn't count. Okay, but they are both shaded on that little interval from 2 to 4. And then I have to choose what kind of circles I want to use based on if they both shade it or if only one of them shades it. Okay, so let's look at 2 first. 2 was shaded on the top. It was shaded on the bottom. Then they agree. But then 4 was shaded on the bottom, but it's not shaded on the top. So I'm going to leave that one open. Okay, remember, we're looking for overlap. So if one of them says to shade it and the other one says not to, that would not count as an overlap. Okay, so then we would say that's from 2 to 4. 2 would be closed, 4 would be open. All right, 2 more left like that, and then you guys will finish up that homework for me. So 1 to 2 is right here, nice and short. And then 2 to infinity would be here to the end of the number line, okay, just like we did yesterday. Remember that for a union, whatever shaded on top, I put it on the number line. Whatever shaded on bottom, I put it on the number line. So basically what I end up having is my 1 to 2 section, and then my 2 to infinity section. Okay, but look at your number line at 2. Did 2 ever get shaded? Yes or no? You can just say it out loud. Did we ever shade in the 2 bubble that was open? No. So what we're going to have to do is this thing up here where we have multiple sections. So we'll say, okay, this first little chunk is from 1 to 2. And then my second little chunk is from 2 to infinity. And then I just realized we're supposed to be doing set notation, so we're going to fix that. Set is the one with the greater than and less thans, so my bad. So let's do that. Remember, you always start your set notation with the little bracket x bar. And then if x is between 1 and 2, remember that I do 1, x in the middle, then 2. And my alligators always eat towards the bigger number, so 2 is bigger, so they're going to open towards 2. And then remember that because they have parentheses, I'm going to leave it like that. I'm not going to put the equal to on there because they're not closed. Okay, comma. Then I have a second set. From 2 to infinity, that's going to be x greater than 2. Okay, and then remember we kind of talked about yesterday, you can think about that's kind of like an arrow. Okay, it's pointing to the right. I shaded to the right, so that's how I know to use that symbol. Okay? All right, then for my next one, let's go back and just do 12. Okay, just humor me here, but since we were supposed to do this notation, you do your bracket x bar, and then if I shaded from 1 to 7, I would do 1, x in the middle, then 7. Alligators always eat towards the bigger number, so they're opening this way, towards the 7. And then I would want to make sure I fill in the closed circle with an equal to. So my bracket was my closed circle, then I have to put an equal to there. Make sense? Okay. All right, one more left, number 15. So we have 1 to 2 open and 2 to infinity closed. Okay, look at your symbol. That's an intersection. Okay, remember for an intersection, you have to look for the overlap. Okay, now, let me be very specific about what we're looking for up here. An overlap, oops, you can't see it, an overlap in shading. Okay, so I want you to think about, when I look at these number lines, I see that these open circles are lined up, but are they an overlap in shading if they're open? Yes or no? Okay, no, Van, you shook your head. That's right, because if it's an open circle, that means it counts as not shaded. Okay, so if neither one of them are shading it, then it doesn't count in an overlap in shading. Then you'd be using this guy right here, the little 0 thing that means empty set. Okay? All right, so what I'd love for you to do right now is get into your Delta Math and do that last section. I'll give you like, we'll do maybe like 10 minutes. I feel like that's more time than you need, but that way you can take a little break if you need to. And then I'm not gonna put you, actually, how many people do we have? 1, 2, 3, 4, 5, 6. Oh. I'll put you in groups. That way, if you have questions, you can work together. If you are totally lost, I want you to leave the main room and come back to my room. Okay, can you do that? So if you're totally confused, if you don't have a Delta Math account, okay, then when I split you up into groups, I want you to just leave the group, come back to the main room, and then I'll do that. Last thing, if you have not put your name in the chat, do it now, because once we break out, you won't be in that chat anymore. Okay? All right.
Ms. Joyner?
Yes. Uh-huh.
14 and 15, they're both open, yet it's nothing for 15 but a set for 14?
Yes, okay, and here's the reason why. Remember that for 14, you're taking any shading off of either number because it's a union, yeah? Okay, so like let's say you have a bunch of apples and I have a bunch of oranges. If we're combining our stuff, we'd have a basket full of fruit, right? But if we're saying like, oh, what do you have that I also have? You'd be like, oh, well, nothing. Does that make sense?
Right. So what if they're both closed for 15? Then?
That is a great question. Okay, let's say that they were both closed and let's say it was at 2. Okay, so I'll put here, if closed, to where you had, let's do closed that way and then closed that way, you would say your set is just that number 2.
So it'd just be like, okay, it'd just be 2.
Yeah, it would be like literally that one dot is the overlap and then nothing else.
And then if it was closed for 14, it would be all real numbers, right?
Well, it doesn't shade all the way to the left, so it would have been 1 to infinity, basically.
Oh, 1 to infinity. Okay.
Does that make sense?
Yeah. Okay.
Cool. Okay, and then let me show you actually one thing on the Delta Math just real quick. I'm going to switch my share screen before I have you break up. Okay, so we're going to Delta Math, blah, blah, blah. You've done it a million times. Okay, once, but we'll call that a million. Then you're going into your account, which you should have made first day of school. If you didn't, I can give you those codes in a sec. Okay, you're in pre-cal. So you're coming down to your homework 1, and then this is the only one that we didn't get to before. So let's just look at a question, make sure you get the idea. So they're not giving you a number line. This is where you maybe having your own paper could come in pretty handy. Or if you can write on your screen or whatever, that's fine. I'm gonna do it on my screen. Okay, so the other thing I would remind you of is that you do not have to put every single dot on the number line. So here's my number line. And then I'm gonna do the top one is from, we'll say -7 is here, okay, and it's open. And then it goes all the way until we'll say -2 is here. Okay, then for my other one, let me switch colors here, I'll do green. Okay, I wanna be from -3, which would be here, open. Okay, until 8, which we'll just say is way over here, that one is closed. Okay, and then this was -3. So you don't have to put like a gazillion little tick marks on your number line. You can just kind of put the numbers that you care about. Okay, then look at your symbol in the middle. Okay, I can see that that is an intersection. That means that I'm looking for where my shading overlaps with each other. So I would say, okay, well then that's gonna be here, this little blue section. And then I would say, okay, well, let's check out my endpoints, right? They have to both agree. They have to both choose to shade it. -3 is shaded on the bottom, but it's not shaded on the top. That means it's open because we're looking for what they have in common. Okay, same with -2. It's shaded on the top. I see it filled in, but it's not shaded on the bottom. That makes it open. Okay, now this is important, so make sure you're watching. When you enter your interval down here, you need to look at what your endpoints are and then choose the correct thing from here. So this first one is a double bracket. I don't want that. This is a bracket parentheses. I don't want that. Okay, I want the double parentheses. And then when I click it, it's gonna open that up for me. Do y'all see that? Okay, and then from there, I can type in, okay, I want a -3 first, then I want a -2 second. Okay, now what if they had no overlap? This right here, this button that I'm showing you, let me circle it. Okay, this is the empty set right here. Hopefully you can see that, okay? But these, I'm not gonna pick that, obviously. I'm gonna submit this answer that I put. Okay, make sense? All right, so go to your breakout rooms. If you're super confused, come back to the main room and I'll help you get where you need to go, okay?
I've already got a question because I started this thing. I've got
sweet.
one where it's open. Do what?
I said, okay, sweet. I'm gonna have you actually share your screen. So I'm gonna stop sharing and I want you to start sharing.
Okay.
And then guys, you can still pull this up even if you're not in a breakout room. You can go ahead and start on your own homework. That's no big deal. Is it allowing you to share it, that green button at the bottom, Thomas?
Clicking that green button, it's not doing anything. Share your entire screen. Yes, yes, I would like to share. Yes. There, I got it.
Here we go. Perfect.
So see how I've got open and a closed. I've got a bracket and a thing on basically on the same number.
Okay, perfect. So you're looking though for an intersection. So think about, can I annotate on your screen? I don't think I can.
Not a dot on the bottom, basically.
Yeah, that would be an empty set because the bottom chooses to shade 0, but the top doesn't. So they basically aren't both shading it. Only one of them is shading it. Does that make sense?
Okay, so
and it'll look perfect. And yeah, see, it shows you that little picture there. And guys, if you get one wrong, it'll show you that picture. Like Thomas gets it because he got it right, but it doesn't matter. You'll see it either way. That way you can kind of visualize if you get several wrong in a row, hopefully eventually you get better at it. Okay? All right, splitting you up. Maybe if I remember how to do it. Maybe I don't. Okay, oh wait, I found it, okay. All right, here you go. And go. Okay, Nathan, I see you're still here. Do you need help?
Hello, miss. It won't let me join the break room.
It won't let you join the breakout room. Do you know how to get into the homework and everything?
Yeah, I think.
it should have sent you a little invite to go into one. Let me try and push you into the room and see if that works, okay?
Oh, yeah, I got it in right now.
Cool. Mike, how's it going? You there? You're gonna have to unmute yourself or I can't hear you.
You hear me?
Okay. So that was your notes from last time. Your notes for this time are on domain and range. You've already seen domain and range like a million times, right? So hopefully this comes back pretty quick. If not, then you guys feel free to unmute yourself, ask whatever questions you have, okay? So I'm looking at your notes 3. Okay, the first thing that we're going to define is how you can tell if a graph is a function. So a function will always pass what's called the vertical line test. You may have heard it called the pencil test before, but basically it just means that if you draw any vertical line, okay, no matter where it is, that it should only intersect the function once. Okay, one time. It's not allowed to cross more than once. If it crosses more than once, it breaks the rule. It's not a function, okay? So take a look at your first graph here. Okay, I'm going to draw my line in. If it touches more than, it has to be a vertical line. If it touches more than once, it fails the test. Okay, so I draw it in. It only hit once, totally fine. Draw it in. Only once, only once, only once. Okay, this is check, yes, that's a function. Okay, now take a look at the next one. Okay, if I draw my line here, okay, automatically right off the bat, you see the problem, right? I have 2 intersections. Both of these spots hit that pink line. That means that it fails the test. It is not a function. Okay, so the first section of your homework is just doing stuff like this, right? Okay, next one, draw your line in. Swing. Okay, boom, hits the circle twice. That makes it not a function. Okay, then for your last one, draw your lines in. No matter where I draw it, it should only hit once. Okay, and every line that I draw, it only touches, like this line touched here, this line touched here, that line touched there. Okay, but none of them are ever hitting that graph more than one time. That means it passes and it is a function. Okay, so that's how you can easily tell if a graph is a function or not. Okay, the other thing you need to know is domain and range. Domain are all of your x values that have a unique, that have a single y value output. Okay, and then your range are going to be all of the y values that have a single x value. Okay. Okay, but realistically, what a lot of, especially when you're looking at the graph, what you're mainly going to be looking for is how far does your graph go to the left, how far does it go to the right, and then how low does it go, and then how high does it go. Okay, so we're looking at this first graph right here, looks kind of like a W. Okay, for your domain, you're going to do the farthest to the left, and then the farthest to the right. Okay, so left has to come first. So if I'm looking at that little W thing, remember domain, these are your X values. That's supposed to be an X there. Okay, so if I were to look at the farthest to the left my graph goes, I can see that it reaches all the way back there to -5. Then I look at how far forward it goes. Okay, it looks like it goes until 4. So I would say from -5 until 4. Then I would look at my endpoints. Okay, remember a closed dot would be a bracket. Okay, an open dot would be a parentheses, but I don't have one of those. Okay, then for my set notation down here, I would say squiggle X bar. My smallest number comes first, which is my -5, less than X, less than 4. Don't forget your equal to's to show that they were closed. Okay, so that's your domain. Now let's look at our range. Okay, your range, I'm gonna put an R here. Okay, that's gonna be your lowest point and then your highest point. Okay, and then you can put here in the side, that's a Y value. Okay, so you're gonna put the lowest the graph goes and then the highest the graph goes. Okay, so I'm looking for my lowest point here. It happens right here. My highest point happens right here. So the lowest that the graph goes, it looks like is a -3. Okay, remember we're giving a Y value here, and then the highest that it goes here in the middle, that's a height of 3. Okay, then I look at those dots to see if they're open or closed. So this dot here, if it's not drawn in to be open, it counts as closed. Okay, it counts as kind of like shaded on the number line. Same thing for that one. If they did not draw in an open dot for you, you would assume that it's closed, okay? So those guys are both closed. And now your domain, you put a little squiggle X bar, but think about for range, that doesn't make sense because we're not using an X as our letter, we're using a Y. So what you would change for range is you would do Y bar at the beginning. And then -3 was the smallest, 3 was the biggest, but I'd put a Y between those. Then remember your alligator's always open towards the bigger number, so they're opening to the right. And then I noticed that they were both closed, so I'm gonna put my equal to's. Okay? All right, take a look at the next one. Okay, domain and range, we're looking how far to the left does it go, then how far to the right does it go. So if I draw my line right here and right here, okay, what is the smallest X or the farthest to the left that my graph makes it out to there? What number?
-2.
Now, I actually thought that at first too, but this is your 1 and then this is your 2. So it actually kind of just like is right there. But I almost put that as well. So it should just be -1. Doesn't quite make it to -2. It stops a little early. Okay, then on my other side, it reaches forward, not quite to 2. It only makes it to 1 right here, and then it turns back around. So that'd be -1 to 1. Then I don't see any open circles, so I know that these are going to be brackets. Let's do our set builder notation. So I do squiggle X bar, YX, because it's domain. And then I would do -1 less than or equal to X less than or equal to 1. And then remember, we're putting those equal to's underneath because it's closed. Okay, now for my range. Okay, I want the lowest point and the highest point. This changes if you have an arrow. Okay, this arrow implies that this graph keeps doing this little snaky thing all the way down to the bottom. So can I say it really has a lowest point if it keeps going down? The answer would be, no, you can't. So your lowest point here would be -infinity, okay, because it goes down forever. Okay, that's what that arrow means, is that it doesn't have a lowest point. It's going to keep going down and down and down. Same thing with the top. You see this little arrow here, right? This is going to keep going up forever. So my lowest point is -infinity. Well, then that makes my highest point +infinity. Remember, infinities are always going to get parentheses because you can't ever really get there, okay? Then for your range, you can use your little symbol that we learned yesterday, okay, and put your little R, or if you just only want to put the R, that's totally fine too. Okay, but what that means basically is I don't have a lowest or a highest point. I can be as high as you want on the graph, as low as you want on the graph, it doesn't matter. Okay? Okay, we have 4 examples left. Almost done, okay? Are we good to keep going? Give me a stop sign if you need me to wait. Or are you guys all good? Okay. And then again, these are gonna be videoed, so no big deal. Okay, take a look at your first one here. I want the lowest point, then I want the highest point. Now, what you're going to notice for this next graph is that you actually have a section of the graph that has a hole in it. So what that means is I'm going to have to break this up into 2 pieces. Okay, I'm going to do a green piece, and then I'm going to do a pink piece. And I'm going to treat those as 2 totally separate graphs, but then I'm going to use my little U symbol, because remember, if I have more than one section, okay, I can utilize that U symbol. So for my green section, okay, how far back does it go and how far forward does it go? Just for my green section. Okay, my X here is -4, and then my X here is 1. -4 I see was closed, but 1 I see here was open. So I'm going to give it a parentheses. Okay, then remember, if I have another section, I put my little U, and then I'm now going to do the pink section. So I'd be like, okay, well, where does the pink line start? So it starts here at 1, but then if it keeps going and going and going forever and ever and ever, because I have an arrow, then I would say that moves forward all the way until infinity. Then remember, my 1 here, that circle was open. So if that's open, that means that's going to be open as well. Okay. All right, now let's jump down here and do our domain and set builder notation. So you're going to do squiggle X bar. Okay, this is called, this is going to be a compound inequality because I have a number on both sides. So remember, it's -4 less than X less than 1, comma, and then I check to make sure my open and closed is right. So my 1 was open, but my -4 was closed. That means I need a little equal to there. Okay, and then for my second part, I'm going to go from 1 to infinity, so that's X greater than 1. And then notice I'm not putting an equal to on it because I want it to show as open. Okay? All right, now let's do our range. So our range is the same thing, right? Okay, the lowest point on the green section, I want to see how low that is here. Okay, I see that's a lowness, we'll pretend that's a word, okay, of -2. And then I want to know the highest that that green goes. So it goes from -2 up, 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 up until here. My circle was at 4. My -2 is closed in, I can see because my dot was filled in, but my 4 is open as I can see from the graph, so that's going to be bracket, parentheses, union. Because remember, I still have another chunk of graph left. For my pink chunk up here, it starts at a height of 4. And then if this side goes up forever and ever and ever because it has an arrow on it, okay, then that means that I would put an infinity for that, okay? And then remember, infinity is always open. Okay, then for my range, I would convert that. So -2 to 4, that's going to be your compound. Make sure you use a Y. And then we would say -2 less than Y less than 4, comma. And then I would see my -2 is closed in, so I'm putting that right there. And then from 4 to infinity, I would use a Y greater than, and then my 4. Okay. All right. So this is unfortunate. I don't know what happened to that graph. It seems to be missing some important features. So we'll just, I guess, skip that one. Okay, so 2 more left then. Lucky you. Okay, next one, come on down to right here. Okay, we're just gonna do domain and range once. I'm gonna do interval notation because that's the one that you're gonna see more in calculus. But you should know both, right? You can always rewrite them later if you want. No, why? You should not. Okay, so let's do this guy right here. So I have a pink section, open. I have a green section. Okay, Thomas is a hater, hating on my other subject. Can't believe it. Okay, so look at your, what'd you say? That's my other subject, is calculus. How could you know, right? How could you know? Okay, so pink section. Remember, I want to know how far to the left does it go? So think about the farthest I see it go to the left is right here. But if I got an arrow on there, okay, that means that's going to keep going back forever and ever and ever and ever and ever. So I would say that that's going to be negative infinity because it doesn't ever stop going that direction. Does that make sense? Okay, but then my pink section does stop right here, which is at -1. So I would say negative infinity to -1, both open, union. Okay, then for my green little chunk, I have a -1 here. That's how far it starts back. And then I can trace all the way across to here, which would be 1, 2, 3, 4. And 4 would be closed, it looks like. Okay. Now, your range on this one's going to be a little bit odd, and here's why. Okay, let's do our pink line first, because it's easier. So I'm looking, remember, so this is going to be the lowest to the highest. Okay, let's do the pink section first, okay? So how low, pretend the green's not here. Okay, nobody sees it, it's gone. Okay, so this is gone. We're looking at the pink section. How low is this dot right here? Give me the Y value, not -1.
It's from
Okay.
0 to negative, I believe.
Okay, so 0 is the lowest, that's correct. Here's where you have to be careful. The highest is up or down. So even though this arrow is kind of pointed backwards, remember for range, I only care about up or down. Is this arrow pointed up or pointed down?
Oh, so it'd be positive infinity.
Yes. Okay, so because this point is going up, it doesn't matter it's aimed to the left, right? That's going to show up here in my domain. Okay, but I'm really looking just for up or down. Okay, and then for my second point, look at this green line segment. Here's the problem. Okay, the lowest on this line segment is -1, -2, -3. That's how low this is. Okay, but then notice it really doesn't touch any other numbers because it's flat. Okay, so what you could do is say, and, okay, put your little U thing, and then you would just do a set with only the number -3 in it. Okay, so when you do your homework, if you ever have a flat line and you're trying to give the range, you just open up those little brackets and be like, and 3. So it's like 0 to infinity and just the number -3. Okay, because that's the only height that that green line touches because it's flat. Okay? All right, last one.
Do a squiggly, not a parentheses.
Correct, because a parentheses, you would need to put 2 numbers in, right? And I'll show you on the homework what that looks like, but they have a little thing where you can open them on the Delta Math or whatever. Okay, last thing. Do you guys remember what asymptotes are? Anybody? No? One of you knows. Who knows? Anybody? That's okay. An asymptote is a line your graph can't touch. Okay, so it's going to get closer and closer and closer to that line, but it's not going to actually ever touch it. Okay, that's like your basically easiest definition to think of. So what this says is I have a vertical asymptote. Okay, that would be this line here through the middle that my graph has to avoid at all costs. So what you're going to notice is that your little curves here, okay, they're going to get really, really close to that line, okay, as I come in closer here, but they can't ever actually go past that green dot, okay, or that green line. Same thing on this side. So you would say that that has a vertical asymptote, at x equals 2. Okay, and then I don't know if you remember if your teacher did like Hoy-Vux. Okay, Vux is for a vertical line, has an undefined slope because it's straight up and down, and it's an x equals equation. Okay, so this is x equals 2. I can never touch that line. Got it? Okay, second type of asymptote is a horizontal asymptote, and that's going to be a flat line. Okay, so I'm going to draw that in here. Okay, and on this case, it's the x-axis. Okay, so we can put here, this is the x-axis. Okay, or you could call that y equals 0, where basically you're saying it's at a height of 0 and it's flat. Okay, so that's where your little Hoy-Vux things comes from. So you could call this y equals 0. Okay, but basically what happens is as your graph travels, okay, it's going to get really, really close to that pink line. Okay, but it can't ever actually get there. It'll get super, super, super close. Okay, but it'll never actually touch 0. Okay, so here's what happens for my domain. I would say, okay, well, how far to the left can my graph go? Well, this arrow is going to go back forever and ever and ever. It has an arrow on the end. So I know that's going to be negative infinity. But then here's the problem. I have 2 different chunks, right? Just like here, remember I had a pink chunk and a green chunk? Okay, this asymptote splits my graph into 2 chunks. So this is going to be, oh, I can't use pink and green. Okay, this is going to be my yellow side over here. It's going to have to get its own domain. And then my range is going to have to get its own domain. We'll say, or I'm sorry, my other chunk is going to have to get its own one. We'll color that one orange. Okay, so let's do yellow chunk first. It can go to the left forever and ever and ever, but when does it have to stop? What x value is it stopping at?
Two.
2 is correct. Okay, now here's the question. Open or closed at 2? Remember, you only choose closed if it actually touches that dot. So if it's a closed dot, I'm choosing to use a bracket. But in this case, if this is an asymptote, I never actually can touch 2, so I would have to leave it open. Okay, and then same thing on the orange side. I would put my little U here to mean I have another section. Okay, and then this one, the farthest back it can go is 2, because remember, it can never cross through 2 to get to where yellow is. They're separated. And then I would say, but it can go forward, okay, forever and ever and ever on the other side. So it would be like that. So I'm going all the way to negative infinity, but I stop at 2. Then my second chunk starts at 2, but goes all the way forward to infinity. That would be your domain. Okay, now for your range. Okay, let's do yellow side first. What is the lowest that my yellow side can go until it gets to that line that it's not allowed to cross? Okay, how low can it go towards this pink line? Well, that's going to be 0. And then I'm putting a parentheses on it because I can never touch it, right? I can get really close to 0, but I can only put a closed dot if I actually get there. Can't ever get to 0 because it's an asymptote. Okay, and then for my highest, remember it's always lowest than highest. Okay, my highest, this is going up forever and ever and ever. So that would be infinity. All right, now, before you guys work on homework, look at your orange here. Do I need to create a separate range for my orange chunk? Okay, think about why. How low does the orange side go? How low does the orange side of the graph go here?
Goes to the x-axis, so 0.
0, which is the lowest point over here. And then how high does it go? To infinity. Yes, which means that really the orange and the yellow pieces have the same range, then I don't have to list it twice. The only time you'd list one for each is if they were different and they kind of like added a new section to the graph. But since they both have the same lowest point and the same highest point, you wouldn't have to put anything there. Okay? All right, so this class ends at 1:50 and it is only 1:11. So you have tons of time to get online and work on your homework. So you are now doing homework 2. Homework 1 should be finished. If it's not, do it first because it's due tomorrow. But then you're going to work on your homework 2, which has 2 sections. Let me pull it up here. Okay, let's go back out of here. So you have your homework here. Oh no, I made it do it 9 a.m. I'm going to have to change that so you can still do it and not get a late grade. But you're going to be, did I not assign this yet? Okay, hang on just take a break. I forgot to post your homework on here. Un momento.
It's on there.
Oh, it is on there for you? Why is it not on there?
the AP Calc question homework 2. Question 1
Yes,
homework
you should-
2.
Okay, maybe I just scrolled the wrong way.
Get out.
Oh, it's because I'm in my calculus class, that's why. Okay, yeah, you should be doing your homework 2 here. And actually, no, this is your calculus. This is my calculus class's homework. I messed something up. Take a minute break. Yeah, that's calculus. You did it? Okay, just stop doing it. Wait like 1 sec and I'll fix it. I think I assigned y'all's homework.
I did the correct